Here are 5 examples, and we are going to attempt to answer these questions. As we go through these questions, I will also teach you how to read and write index notation. Let's start with the first question. The first question says, write 10 times 10 times 10 times 10 in index notation. So, before we answer any question, we have to identify the keyword. Keyword as write, and index notation. So from this, we know we have to write something, and we write it in index notation. So we just went through the terminology of index notation and basically what it consists of. So it always has a base and an index or an exponent or a power. All of these things basically are the same thing. So have to write this in index notation. So for that we need a base. We need a base and an index. So let's go back to the definition of what a base is. Well, a base is a number that's constantly being multiplied by itself. In this example, what is the base? Well, the only number that we see being constantly multiplied by itself is 10. Therefore, the base is 10. Now that we have identified the base, let's identify the index or the exponent, whatever you like to call it. The exponent is basically the number of times the base has been multiplied by itself. So in this example, we have to ask ourselves, how many times has 10 been multiplied by itself? How do we determine that? Well, we can determine that by seeing how many times 10 has been repeated. 10 has been repeated once, twice, 3 times, and 4 times. Therefore, we can say that the exponent is 4. Now that we know all of this information, we have to write our answer in terms of index notation. So 10 times 10 times 10 times 10 times 10 equals, first we write the base and then we superscript the exponent. So 4 is our exponent and it's at the top. That's what being superscripted means. So this right here is in index notation. And when a question asks you to write something in index notation, this is basically what it means. It means you have a base here and have an exponent here. Now let's try to read this index notation. So first we read the base and then we read the exponent. In this example, we would read 10 times 10 times 10 times 10, which equals to this figure right here as 10 to the power of 4. So I'm going to write this out. 10 to the power of 4. So in here it's clear that we start by reading the base. So what is the base? The base is 10. So we start with 10, and then we move to the exponent. And the exponent here is 4. So verbally we have to say 10 to the power of 10 raised to the power of whatever the exponent is. So in summary, you start off by saying the base, and then you say the phrase raised to the power of or to the power of, and then whatever your exponent or index may be. So that is how we read index notation. And this example already showed you how we write index notation. Now that we have understood this, let's move on to the second example. In this example, it says, write 1 times 1 times 1 in index form. So basically that means write it in index notation. So this question wants us to write 1 times 1 times 1 in index notation. So as with all questions, you need to break it down. So index notation, you need a base and you need an index. And we've seen this in the previous question. So we have to, step 1 is to identify the base. What is the base here? Well, the only number that's been constantly multiplied by itself is 1. So the base is 1. So you can write 1 times 1 times 1 equals 1. And it's raised to the power of something. How many times has 1 been multiplied by itself? Let's count. Once, twice, 3 times. So the index is 3. So this is the answer. This is an index notation. Now, something I would just like to point out with this question is that yes, 1 times 1 times 1 equals 1 to the power of 3, or 1 cubed. But writing it like this, 1 to the power of 3, is the same as writing it as equal to 1. Why? So 1 times 1 times 1 equals 1, because 1 multiplied by anything is itself. So it doesn't really make a difference whether we write this 3 or not. It's more correct to write it as 1 cubed. But if you don't write it as that, your final answer won't change. However, since this question wants us to write it in index form, meaning a base and an exponent or an index, we probably should write it as this. But in any other question, like for example, when you're trying to evaluate number that's written in index form, it's not necessary to write as 1 cubed. You can just simply write it as 1. Question 3. Write 1 to the power of 10 in expanded form. So we just said earlier that whether 1 is raised to 3 or 10, it doesn't make a difference in the final answer. We know that the final answer is 1. Okay? That's just something I would like you all to keep in the back of your head and remember this. So write 1 to the power of 10. Now we have to write it in expanded form. So we know that 1 is the base. And that basically means that 1 is being constantly multiplied by itself. Now 10 is the exponent. And that means that 1 has been multiplied itself for a total of 10 times. So like we write 10 spaces, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 10 spaces because the exponent is 10. So 1 has been multiplied itself for a total of 10 times. And in the spaces we write the base, because that's the number that has been constantly multiplied itself. So we write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is how you write 1 to the power of 10 in expanded form. You determine what the base is, and then you determine what the exponent is. And you think, okay, now that I have identified this, what does this all mean? Well, this means that you write 1, and you also write how many times it has been multiplied by itself. And that's determined by the exponent. So this is your answer to this particular question. Now, let's move on to question 4. Question 4 says, similar to the previous question. Question 4. Write 4 to the power of 6 in expanded form. Step 1. What is your base? Well, your base is 4. What's your exponent? 6, because that is the number that is superscripted. 6 is your exponent. Start off by writing 4 to the power of 6, and now we have to write it in expanded form. So you're going to have a total of 6 numbers because the number 4 is being multiplied by itself 6 times. So let's write that out. 4 times 4 times 4 times 4 times 4 times 4. Let's count. 1, 2, 3, 4, 5, 6. I've written the correct number of times 4 has been multiplied by itself. So this is your answer. 4 to the power of 6 written in expanded form is 4 times 4 times 4 times 4 times 4 times 4. Final question. Question 5. Question 5 says, write 5 in index notation. So at first you might think that this is strange because 5 is the base, but where is the exponent? There is no exponent. But you are wrong. Even if there hasn't really been a number written at the top, every single number has an exponent. So in this case, the exponent of 5 is 1. Because if you recall, in the example of 1 cubed, I believe, we said that that equals to 1. The same applies here. If we try to write 5 in expanded form, you write 5 as the base and 1 is the exponent. That means that 5 has been multiplied by itself only one time. There's not going to be another 5 because the exponent is 1. It's only been multiplied by itself once. So 5 to the power of 1 is the same as 5. But wait, look, we have 5 here and 5 here. And it's asking us to write it in index notation. And that means we need a base and we need an exponent. Well, our base is 5, right? And our exponent is the number of times 5 has been multiplied by itself. We just said that in these situations, 5 has been multiplied by itself only once, right? Therefore, the exponent equals 1. So, if we were to write an index notation, 5 equals 5 raised to the power of 1. That is your answer. So, just reiterating what I have just mentioned, I would like to say that every number has an exponent. In fact, it's so important that I'm going to write it out. Each number has an exponent. So 2 has an exponent, 3 has an exponent, 100 has an exponent, 7 has an exponent. There is no number written at the top, no number superscripted, but that's because it's all raised to the power of 1. And that basically means, in this situation, for example, 7 to the raised to the power 1, that equals 7, because 7 has only been multiplied by itself a total of 1 times. The same applies for all these other examples. If you enjoyed this video, give it a thumbs up and subscribe to my channel for more informative videos.